of resistors in series and parallel. So, first difference, only one path for current to flow through resistors. Different path for current to flow through resistors. See, I have drawn the figure over here. This is combination for series, this is combination for parallel. You can see over here, the path of the current is only one path. The current flows from R1 to R2, R2 to R3, only one path is there. Here you can see the current is different, bifurcated, I1, I2, R3. So the current flowing through this parallel connection is different. The flow of current is different. Second difference, current remains same throughout the circuit. You can see the current throughout the circuit remains the same. It will never change. Here the current is different throughout the circuit because as the path is different, the amount of current flowing through resistor 1, through resistor 2, through resistor 3 will be different. So I1, I2, I3. Potential difference is different across each component. Potential difference means voltage. So the voltage is different in R1, R2 and R3 because current is constant. The voltage changes in series. Why in parallel? Current changes, the voltage remains the same. The potential difference remains the same. In R1, R2 and R3, the potential differences are same in combination in series. These are the differences between combination of resistors in series and parallel. Now let us see what are the advantages of series and disadvantages of combination in series. First let us see advantages of combination in series. First advantage, do not overheat easily because the flow of current is constant throughout the resistors. The devices do not get overheat very easily. Second, easy to learn and to make means the resistors are joined side by side, so we can join the resistors very easily and we can learn the resistance of the combination in series very easily. Third, can add more power devices having together and putting in terms of voltage, means as many as power devices you can go on adding because the voltage, the terms of the voltage will go on increasing because current is constant in series, voltage is different. So we can add more power devices. This is very important advantage of combination in series. Fourth advantage, current will flow through each component, it will be constant. How many resistors, how many power devices you add through in the combination in series, the flow of current will be the same. There will be no change in flow of current. Fifth one, easy to control the flow of current. You can increase or decrease the flow of current very easily because the current is flowing in only one direction. It will flow in one path only, that is why. Next, disadvantages of combination in series. What are the disadvantages? Very important disadvantages are there. If one point breaks in series, the circuit breaks. This I can give you the example where in functions you take the serial lights. In serial lights, if one light does not work, then the whole line of lights won't work, it will break. So if one point breaks in series, circuit breaks because the current is flowing from one device to the other device in the one path only. So if the first device does not accept the current, all the other devices also won't get the current. So there is a break in circuit if one point breaks in series. The serial set is a better example for this. If one of the bulb does not glow, then the whole series will also not glow. Second, as number of components in circuit increases, greater will be circuit resistance. Means the resistance increases, the heating effect also increases. So that component efficiency will be less. So that is one more disadvantage in combination in series, because the number of components increases, the resistance also increases. More the resistance, more the heating. So the heating of the device takes place very fast. So its working efficiency decreases. These are the advantages and disadvantages of combination in series. Same. Now let us try to learn the advantages of combination in parallel. The first advantage says provide same voltage to every device and appliances. How many devices and how many appliances are combined in the parallel? In all these devices and all these appliances, the voltage is same. The voltage does not change. If one appliance is fused in circuit, the current continues to flow through other appliances and work efficiently. That means if any of the combination in parallel, any one of the device or one of the resistor does not work, fused in circuit, means the current fails to flow through that. It doesn't mean that the whole circuit will be open circuit, but the current will be flowing through the other appliances, because in parallel the path of the current is different for each device and each appliances. Remember that for each device and each appliances, I can show over here. If this I can show. So you can see here the current flows in different direction. If this resistor, the current is not flowing, it means only this resistor won't work, but other two resistors or other two devices will work if they are connected to the electric source. That is very important in this diagram. I am explaining you that the flow through other appliances will not be interrupted. The circuit will be closed circuit and the work will be efficient. So the working of other devices and appliances will be efficient. That is why such connections are preferred in household, because if in one room the light get diffused, in other rooms the light will be working. In one room the fan is not working, in another room the fan will be working, because the wiring will be done in what the combination will be in parallel. So the flow of current will be constant in other devices. If one device get diffused or current is not there in one device, this is more advantage of combination in parallel. Let us see what are the disadvantages of combination in parallel. Very important thing, it requires more wire. That is what I told you. In household wiring, when we use parallel combination, to each room separately the wiring is required. So more wire is required. So the costing will be also more. Draws more power, so costing is more, because the current is divided according to the requirement of the appliances. That much current is drawn by the wire. So what happens? The power is required more, so the costing is more. Causes more heat as power is more. When the power increases, the heating effect also increases. So it causes more heat as power is more. These are the disadvantages. Though disadvantages are there, but advantages are more in parallel than in series. So in household supply, the connection will be in parallel. Combination in parallel is preferred than in series. Let's see the next topic, effects of current. There are three important effects of current. One is heating effect of current, second one is magnetic effect of current, and third one is chemical effect of current. Heating effect of current is in this chapter only, electricity. Magnetic effect of current is in the next chapter, which is named by magnetic effect of electric current. chemical effect was in your previous classes. Heating effect means whenever the current is flowing in a device, for example, you are using a mixer grinder. You have taken some rice to ground it into flour. When you on the machine will start working. You have used that grinder machine for 10 continuous minutes. You switch off the grinder machine and you touch the machine. You will find the machine has become hot because what is the reason? The electrical energy which is flowing through the electric source passes through the mixer grinder. Some part of the electrical energy is converted into heat energy. So the device gets hot, and that type of effect is called as heating effect of current, where the devices or the copper wire, for 5 minutes you pass the current. After 5 minutes you switch off and you touch the copper wire. You will find the copper wire is hot. What has happened over here? Some part of the electrical energy is converted into heat energy, and this is called as heating effect of electric current. Similarly, the next is magnetic effect. What is meant by magnetic effect? If a magnetic needle is brought near a conductor carrying current, immediately the magnetic needle will deflect. Deflection is there, movement in the magnetic needle is there. That means the electric current has magnet which makes the magnetic needle to deflect. That is magnetic effect of electric current, which you are going to study in the next chapter in detail. Chemical effect, battery, cells, all these are there. They are the chemical effect of electric current, because cells and batteries are made up of chemicals. They are able to produce the current, and that means chemical, when the source of current passes through them, the chemical effect takes place and converts the chemical energy into electric current, which we can say that the chemical effect of electric current. These three effects are there, but we are going to study now the heating effect of electric current. When current passes through a conductor, after some time the conductor becomes hot. This is due to conversion of some part of electrical energy into heat energy. This effect is called as heating effect of electric current. So now let us see what is meant by heating effect of electric current. When current passes through a conductor, after some time the conductor becomes hot. This is due to conversion of some part of electrical energy into heat energy. This effect is called as heating effect of electric current. Previously I explained you, I gave you an example of mixer grinder. You use this mixer grinder for 10 continuous minutes. When you touch the bottom part of the mixer grinder, you will find it is hot. What is happening over there? When current passes through a conductor or through any electrical appliances, when current is passing continuously, After some time, the electrical appliances or conductor becomes hot. What is the reason? This is due to conversion. Means the electrical energy conversion of some part of electrical energy. The electrical energy which is flowing through the device or through the conductor, some part of this electrical energy gets converted into heat energy. Very important. It gets converted into heat energy, and this heat energy makes the device to become hot. And this heat energy is because some part of electrical energy is converted into heat energy. So the electrical energy is producing the heat energy. That is why it is called as heating effect of electric current. So this effect is the heating effect of electric current. Let us see now what are the applications of heating effect of electric current. In which devices this principle is used? First one is your iron box. You know that you want to press your clothes. You will connect the iron box with the electric source. You switch on, the current will start passing through the iron box and the iron box get heated. This is heating effect of electric current. So you can press your clothes neatly and nicely. Second one is electric heater, where the water can be made hot and there the current passes through the water and some part of the electrical energy is converted into heat energy, which makes the water to get hot. That is your electric heater. Third one is your electric stove, where you can find in the electric stove a nichrome wire coil is there like this. When the current passes through this coil, the current gets converted into heat energy and the coil gets become red hot, and when you put the things on that to cook, the things will get cooked. That is electric stove, which works on heating effect of electric current. So these are the applications or devices. Some more devices are also there which you have to find out and say which works on heating effect of electric current. But these are the three main devices: iron box, electric heater and electric stove. Even in industries also, the heating effect of electric current is used. Big boilers are used to heat the water. There also the same heating effect of electric current is used even in industries, especially in boilers, where the water is boiled with the help of electric current. There also you will come across heating effect of electric current. These are the applications of heating effect of electric current. Now let us see regarding Joules law of heating. Joules law of heating. Let us take that in a resistor having resistance R, flow of current is passing through the circuit as I. The potential difference is V and the charge flowing through the circuit is Q and the time taken is T. Previously in potential difference we saw that work done, potential difference and charges are interrelated with each other. V is equal to W by Q. So what is work done? Work done is nothing but the product of potential difference and the amount of charges flowing through the circuit. So the work done in this particular circuit is V into Q, where V is potential difference and Q is, we have already seen in potential difference that the work done W, the potential difference V, and the charges are interrelated with each other. We know that potential difference is equal to work done by charges. So what is work done? Work done is given by potential difference into charges V into Q. So power input in the circuit is denoted by P, which is equal to V into Q by T, where Q by T we know that it is the current. So we can say the power input in the circuit is given as P is equal to V into I. If power is there in the circuit, then what will be the heat energy? Because last only I told you, whenever the current is passing through the circuit or through any appliances, some part of the electrical energy is converted to heat energy. What is that heat energy given as? The heat energy dissipated is nothing but the product of the power and the time taken the power to pass through the appliances. So H is equal to P into T, but we know that what is power? We got the equation over here. P is equal to V into I. So instead of P I am going to keep it as H is equal to V into I into T. We already have studied Ohm's law, so we are going to apply here Ohm's law. According to Ohm's law, what is potential energy is equal to current into resistance. R is equal to V by R, so V is equal to I into R. So instead of potential difference, I am going to take V as I into R. So it will become I into T into R, which I can show over here now. C is equal to I into R into T. What is I into I? I into I is called as I square. So H is equal to I square into R into T. This particular equation is called as Joules heating law. Joule found out this equation, so it is named after him. What is the heating law of Joule says that? It is nothing but it is a product of square of the current, the resistance and the time taken to pass the current to the circuit is called as Joule's heating law. The Joule's law of heating can also be explained as it is nothing but heat is directly proportional to the following. First one, square of the current. So it is denoted by I square. Current symbol is I square. Square of the current passing through the circuit. B, resistance for a given current. The resistor which is joined to the circuit, its resistance. C, time for which the current flows. How much time the current flows through that circuit? It is given by T. I is given in ampere, R is given in ohms and T is given in second. So directly proportional to I square, R and T. So we can say that heat is equal to the product of I square into R into T. This is the Joule's law of heating. You have to remember this. This will be asked for 1 mark. What is Joule's law of heating? So heat is directly proportional to the following. A, square of the current I square. B, resistance for a given current R. C, time for which the current flows through the circuit T. So therefore H is equal to I square RT is your Joule's law for heating. Sums based on this, the next we are going to see. Let us see sums based on Joule's law of heating. First sum. What is given is first sum, let us try to understand. An electric iron box consumes energy at the rate of 840 watt. 840 watt is the power of the electric iron box when heating is maximum rate. So when you switch on the iron box and when the heat becomes maximum, the power used is 840 watt. And when heating is minimum, it is 360 watt. When heating is at minimum. The voltage is 220 volts. So the voltage is same when the heating is maximum, that is 840 watt also the voltage is 220 volt, and for 360 watt also the voltage is 220 volt. You have to find out what is the current due to resistance in each case. Already when we were seeing the Joules law of heating, I told you one equation. Power is equal to potential difference into current. This equation we are going to use. In this case, we have to find out what is the flow of current when the heating is maximum, that is the power is at its maximum, that is 840 watt. So here P is given as 840 watt and the voltage is 220 watt for both. So we are going to use this equation, that means I is equal to P by V. So what is the power given over here? 840. What is the voltage? 220. 0 cancels. 2 ones are 2 ones are. 2 fours are 8. 2 twos are 4. So 42 by 11. So let us divide it. 42 by 11. 11 threes are 33, 11 fours are 44, won't go. 11 threes are 33. So 12 minus 3 is 9.00. 11 eights are 88. So 88. So one place of decimal is enough. So we got it as 3.8 ampere is the current flowing through the maximum that is maximum rate of power 840 watt. Same way, using the same equation, let us try to find out in case 2 change is there. What is change? The power has become minimum. How much is the minimum power? 360 watt. At that time, what will be the current? So we are going to take the same equation over here. I is equal to P by V. Power is how much now? It is 360. And how much is the voltage? The same voltage. 0. 2 ones are 2 ones are. 2 ones are 2. 2 eights are 16. So we got 18 by 11. Let us try to divide and find out what is the answer. 18 will go inside, 11 will come outside. 11 ones are 11. 8 minus 1 is 7, 0.00. 11 6 are 66. So one place of decimal. So we got the answer as 1.6 ampere. So you can see in this sum, if the heating is maximum, the amount of current used is also maximum. If heating is minimum, the amount of current used is also minimum. This is what regarding this sum. In part 1 we saw to find out the current. So I told you the formula we are going to use, I is equal to P by V. But there is second part also where we are going to find out what is the resistance. We know that according to Ohm's law, resistance is equal to potential difference by current. Potential difference is already with us. So taking that, R is equal to V by I. Taking this formula, we are going to find out the resistance when it is maximum and the resistance when it is minimum. So here V is 220 divided by 3.8 is equal to 2200 divided by 38. So we get the answer as, if you divide it, we get the answer as 57.60 ohms is the total resistance when the heating is maximum, that is the power is 840 watt. So if you divide it, you will get 57.60. In the same way, in case 2, the part 2 we have to see. There also we have to find out the resistance. There also we are going to use the same formula. R is equal to V by I. So substituting the value 220 by 1.6. I am going to remove the 0 over here. Same what I did over 0. If I remove from the denominator, I have to add one more 0 in the numerator. So it will become 2200 divided by 16, which comes up to 134 ohms. So that much is the resistance. So you can see here that what happens when current becomes maximum, the resistance is less. When current becomes minimum, the resistance is more. This is what we can derive or we can see in this sum. When the heating is maximum, he tells us to find out what is the current when power is 840 watt and the voltage is 220 watt. And also he says us to find out what is the resistance at the same time when the heating is maximum at 840 watt and the current is and the voltage is 220 watt. Similarly, when heating is at minimum, it is 360 watt, the power is 360 watt and the voltage is 220 watt. So what will be the current and what will be the resistance? So two parts are there in case 1 also and case 2 also. So we can see through this sum that if the power increases, the current increases but the resistance decreases. If the power decreases, the current if the power decreases, the current decreases, the resistance increases. Now let us see the second sum. 100 joules of heat is produced each second. Each second means 1 second in 4 ohms resistance. Find the potential difference across the resistor. To find out the potential difference, we need the current. We know that using the Ohm's law, R is equal to V by R is equal to V by I, so V is equal to I into R. So to find out potential difference, we need resistance. Resistance we know, the resistance is given 100 joules, the heat is given, but we don't know the current. So with the help of the Joules law heating equation, so first we will find out what is the current, then we will find out what is the potential difference using Ohm's law. So let us first write down what is the given. So given we know H is equal to 100 joules. So the heat is given. Then resistance is given. Resistance is equal to 4 ohms. And the time taken is 1 second. Using the equation H is equal to I square RT. So what will be I square is equal to? Therefore, I square is equal to H divided by R into T. So what is the value of H? Let us try to see. The value of H is 100. What is the value of R? R is 4. What is the value of time? 1. So you got it as 100 by 4. We can cancel 100 by 4. 4 2s are 8. 10 minus 8 is 220. 4 5s are 20. So we got it as 25. So I square is equal to 25. Then I will be equal to square root of 25. 25 is a perfect square. What is square root of 25? 25 is 5. So we got the current as 5 ampere. So we got the current is there, resistance is there. We can find out potential difference by using Ohm's law. So what is R is equal to V by I. So using that equation we can say that therefore V is equal to I into R. So what is I over here? 5. What is R over there? 4. So we got 20 volts is a potential difference across a resistor of 4 ohms when 100 joules of heat is produced by it. This is what we are using the Joules law of heating equation. They may ask you for 1 mark. What is the Joules law of heating? Or write the equation for Joules law of heating. This is the equation. H is equal to I square RT. So here heat is given, resistance is given, time is given. So we have to find out I. So we can take I square, you keep it on right hand side. R and T when you bring, it will go into the denominator. So we get an equation I square is equal to H by R into T. Substitute the value of H, R and T, 100 by 4, 25. Root of 25 is 5 ampere. We know according to Ohm's law, potential difference is equal to current into resistance. 5 into 4 is equal to 20. So we get this as 20 ohms 20 volts is the potential difference for this sum. So remember, H is equal to I square T is very important equation. You can use this equation to find out the resistance, to find out the time, and to find out the current. This is what we are using over here.